Today's video is on the classification of matter. All substances can be classified into one of two groups. They're either pure substances or mixtures. A pure substance can be an element or a compound. The makeup of a pure substance is the same throughout and does not change from sample to sample. What that means is that if you take water from one place, it's going to be made of the same exact things and is the same exact amounts as water from a different source. Same thing with, my dog's groaning in the background. Same thing with salt or sugar or everything else. So pure substances have the same chemical makeup no matter where the source is. Mixtures can contain more than one substance, and mixtures also vary, or they are different in both composition, which means what it's made of, and the properties depending on where you get these samples from. So for example, if you take muddy water from Thailand and you analyze everything that's in the muddy water, it's going to be different than muddy water that you find from, let's say, China or the US or the UK. So the focus for today is going to be on mixtures because I talked about elements and compounds in the previous video. A mixture is a blend of two or more kinds of matter, each of which keeps its own identities and properties. What I want you to think about when you are distinguishing between pure substances and mixtures is that, let's say, I think I mentioned it before when I talked about water. If I didn't, then this is new, and if I did, it's review. So water is made of hydrogen and oxygen. Both of these are colorless gas. And they're both highly flammable. I'll just write it in the middle, highly flammable. And so those properties are completely different than the property of water, which is odorless, tasteless, clear, liquid. So if you take two colorless flammable gases and you combine them chemically together, you get an odorless, tasteless, clear liquid, which is necessary to sustain life on this planet. Separately from that, I'll go up here. If you look at salt water, let's say salt, and we have, remember these characteristics. What are the characteristics of salt? It's white, it's a solid, tastes salty. Yeah, there we go. And what are the properties of salt water? It's a clear liquid that tastes salty. So clear liquid comes from water and taste salty comes from salt. So the mixture of salt water contains properties of both salt and water, the two things that made it. So that's a big difference. What you want to think about when you are determining if something is a compound or a mixture is, does this have the same properties as the things that make it, or are the properties of this substance, sorry, I just came inside, I'm like super sweaty. Or does this substance have completely different properties than its parts? Those are the two things you're going to think about. So the parts of the components are just simply mixed, which means if you use a physical method to mix them, you can use a physical method to separate them. That's another big difference between a mixture and a pure substance. Pure substances are made through chemical change, which I talked about in the previous video, and they are separated through a chemical change. Mixtures are made through a physical change, and so they are separated through a physical change. So if we go back, whoa, I got a lot of writing. So if we go to, oh no, I do want to do that. If we go back to the salt water example, how would you separate the water from the salt, which means I want the salt, I don't want the water? You would probably either boil it or you would just let it sit there for a few days. Eventually the water evaporates. Evaporation is a physical change and you are left with just salt. If, however, you want to separate the salt from the water, which means you want the water, you don't want the salt, what you could do is when you are evaporating it or boiling it, you capture that water vapor and you condense it separately. That's called distillation, which I'm going to talk about in a later video. But the bottom line is that if mixtures are put together physically, they are separated physically. Now, there are two kinds of mixtures depending on whether or not you can see its parts. The first one is called homogeneous. The prefix homo means same. So that means that the components are uniform in distribution, which means everything is spread out evenly. Another name for homogeneous mixtures is a solution. So if I use the word solution, I specifically mean a homogeneous mixture. Excuse me. For example, if you put sugar in water or salt water, etc. So what that means is that when the mixture is complete, I can take, let me go here, just to give you an example. If I have a glass of water and I add salt, once it's all dissolved, I can take a sample from any part of that mixture and I will get the same amount of salt and water. That's a solution. Or a homogeneous mixture. Okay, now a heterogeneous mixture, hetero means different. So that means that the component parts are not the same throughout the mixture. An example of this is sand and water. So if you, in this picture on the left-hand side, you see a homogeneous mixture, it is the same in all of the parts. On the right-hand side, it's a heterogeneous mixture. It is not the same. You can see that there's more stuff, let's call it stuff, because I don't know what it is dissolved, more stuff on the bottom than there is on the top. It is not the same throughout the mixture. And finally, we have pure substances. They have a fixed composition. That means that what the substance is made of never changes. That means fixed. So how a pure substance is different from a mixture. Number one, every sample of a pure substance has exactly the same characteristic properties. Like I said before, if you take salt from anywhere in the world, it's going to have the exact same properties. If you take muddy water from all different parts of the world, every sample will have different properties because it's a mixture. Number two, every sample of a given pure substance has exactly the same composition. So again, with the water, every single water sample in the world is made up of 2 parts hydrogen and 1 part oxygen. We classify pure substances as either elements or compounds. Compounds can be broken down by chemical change. Elements cannot, because elements are the most basic form of matter. In this video, you are seeing what's called the electrolysis of water, which is breaking water into its component parts. Now, they put a battery in there because a battery supplies electricity, and that electricity is what starts the chemical change to allow the hydrogen gas from the oxygen gas to be split. So those are the bubbles that you see forming. So to break it down, you have at the top, everything's made of matter. The questions that you ask yourself when you're defining what kind of matter it is, whether it's a homogeneous or heterogeneous mixture, or if it's a compound or an element. Can it be separated? If it can be separated, and when they mean by separated, that means like physically. If it can be separated, yes, then it's a mixture. No, pure substance. So if your answer is yes, it can be separated, then you ask yourself the next question. Is the composition uniform? Is it the same throughout the mixture? If yes, it's a homogeneous mixture or solution. If no, it's heterogeneous. If your matter cannot be separated, it's a pure substance. The next question, can it be decomposed or broken down chemically? If yes, it's a compound. If no, it's an element.